The topic we will discuss today is gravitation. Under the gravitation, we will discuss a very special case of a gravitation, which is a gravity. So, first of all, we need to understand what is gravity. Gravity is a special case of a gravitation force, and it is applicable for a massive body only. That means we can say for heavenly bodies only. So, the body is accumulating a very huge mass in its own, then they will show the gravity. So for bodies having very minimum mass or mass which is negligible in comparison to a earth will not show the gravity. So in case of an apple and an earth, we will talk about the earth only because an apple doesn't possess any kind of gravity. So continue our topic. So it is clear for us that gravity is a special case of a gravitational force. So if this is a force, then it is confirmed that it has some acceleration. Okay, so that acceleration will be known as acceleration due to gravity, and that will be denoted by g only. So here we can write acceleration due to a gravity by the virtue of gravity is called acceleration due to gravity. Acceleration due to the gravity, it is denoted by g. So using our gravitational formula, what we have? We have gravitational force. This is the mass of Earth. This is a unit mass, and that will be the distance between them. That is the radius of Earth. We are supposing here that the object is placed exactly to the surface of Earth only. So we are neglecting the radius of that particular object because radius of that particular object is really very small in comparison to the radius of Earth. So now force can also be decided or can be defined as m into a. Here this acceleration will be replaced by g only, that is acceleration due to gravity here. So if you are talking about the fg, in this case that will be m into g. Now using equation 1 and 2, what we have, mg equals to r square. Here m will be cancelled out by this. So we have a formula of acceleration due to gravity for Earth's surface. Now, we can also calculate the magnitude of this acceleration due to gravity by placing the values over here. So, g will be 6.67 into 10 raised to the power minus 11 Newton meter square upon kg square, and mass of Earth will be considered as 6 into 10 raised to the power 24 kg. Radius of Earth will further consider as 6,400 kilometer. So here square will be, this kilometer will be further written as 6400 into 10 raised to the power 2 meter. So on calculating all these values, what we have? We have 9.8, and the value of acceleration, unit of acceleration is meter per second square. So this will be the value of acceleration due to gravity. Now consider a very special case of the gravity or acceleration due to gravity, that it will vary according to the radius of Earth, it will vary according to the altitude of Earth, it will vary according to the depth if we go on, and it will vary according to the shape of the Earth also. It will also vary with the rotation of Earth. So discuss the first case, that what is the variation in gravity or acceleration due to gravity due to the altitude. Let us suppose at height h we want to calculate the value of g. So first case will be variation in g due to altitude h. So consider Earth having radius earth r. Okay, so this is our r, earth. Now what we need to calculate, we need to calculate acceleration due to gravity at this height h. So this will be the height h. At this height, let us suppose we have acceleration due to gravity is g dash, and at the surface we have already g. So, and this will be the radius of earth r itself. So what we can do, we already know that acceleration due to gravity at the earth's surface is gm upon r square, which is our equation 1. At height h we have g dash, and g dash is supposed to be gm upon r plus h square on dividing equation 2 by 1. What we have? We have g dash upon g, gm upon r plus h square upon gm upon r square. So we have gm and gm cancel out over here. So this will become r square upon r plus h whole square. If we multiply our g over here, it seems like that. Further, we can cancel out our r square by taking r common from our denominator. This will give 1 plus h upon r square. Now, by seeing this formula, we can clearly see that our acceleration due to gravity at the Earth's surface is divided by some kind of magnitude radius 1 plus h upon r whole square. So this will definitely varies our g at height h. So from the formula 3, we can clearly see that g dash is smaller than g. So as we go upwards, the acceleration due to gravity will decrease from Earth's surface. Now, this is the formula we will use when h is considerable with respect to r, that is radius of r. So this formula we will use when h is greater than 100 kilometer, okay, which is considerable. Now what happens if h is really very small? Now suppose I am dropping an object from 2 meter height, then what is the variation of g and g dash at 2 meter of height? So we can further formulate the equation 3 like this. Now using binomial expression, what we have? We have g1 minus 2h upon r. Okay, here I am neglecting here higher order terms of h upon r. So this will give you a value of g dash at height h. Okay, 4. Now this equation 4 will be used when h is really small in comparison to r. When, or we can say when h is less than 200 kilometer. So in this way, the variation of g takes place according to the height h or altitude h.